During a locust plague, the area of land eaten is given by A equals 8,000 times 2 to the 0.5 n hectares. So hectares is a unit of area, where n is the number of weeks after the initial observation. Find the size of the area initially eaten by these locusts. B, find the size of the area eaten after part 1, 4 weeks, part 2, 7 weeks. Graph A against n. Now I'm not going to do a plotted graph. I'm not testing if you can plot graphs in this. I'm testing if you can interpret the equation and use your calculator skills. So I will show a little sketch as working, and I will graph it in the calculator, but I'm not going to graph it on graph paper for this particular bit of work. Part D, how long would it take for the area eaten to reach 50,000 hectares? So again, that will be the calculator using the solving method. So let's write down the formula. So A equals 8,000 times 2 to the 0.5 n. So n is the number of weeks after this locust plague starts. So you've got all these locusts, these insects, and they're eating land. Find the size of the area initially eaten. Now initially means when no weeks have passed. So part A, basically you're using n equals 0 when n equals 0. So often you'll be asked for initial conditions for these sort of exponential modelling type questions, and it just means when t equals 0, when n equals 0. So I just literally need to substitute 0 into there. So A equals 8,000 times 2 to the 0.5 times 0. So you shouldn't really need a calculator for that, because this is 0.5 times 0 is 0. 2 to the power 0 is 1, because anything to the power 0 is 1, apart from potentially 0. So 8,000 times 1 is 8,000. So, and that is hectares. 8,000 hectares, the initial area. Part B. Find the size of area eaten after 4 weeks, 7 weeks. So now we are going to use the calculator. So part 1, we know that A equals 8,000 times 2 to the 0.5 times 4 weeks, that n must be 4. So we just put it in like that. Go to your calculator and type it in exactly how it looks. So 8,000 times 2 to the power. Use a bracket to be safe. You probably could get away with not using it, but you're better off using it if you're not sure. So 0.5 times 4. You could work out 0.5 times 4, but seeing as I've got to do a second part as well, doesn't really help you in the long run. And that gives us an answer of 32,000. So that means that 32,000 hectares have been eaten after 4 weeks. So write hectares. Part 2, the A is going to be 8,000 times 2 to the power 0.5 times, this is 7 weeks, so that must be a 7. So on your calculator, can I go up and, yeah, I can use the arrow keys. I can get in there and I can just delete the 4 and turn it into a 7. Another option could have been table mode, or even to plot the graph and use the trace. And that gives me 90,509. 90509.66799. Does it ask me to round anything? It doesn't ask me to round, but probably 3 significant figures might be a good option. So 1, 2, 3. It's not going to round up because it's a 0 next to the 5, so I'm going to call that 90500 hectares. 2, 3 sig fig. So now we're on to the graphing bit. I'm just going to draw a line here. It's not really left myself enough space. So graph A against D. So we need to go into the graph feature. If you've got anything in here, clear it. If you've got a Y2, clear it. So I want to draw 8,000 times 2 to the power of, I'm going to use a bracket, 0.5. I don't really need this bracket, but I think it's best. 0.5x, put a bracket there. So let's have a look. And how it looks really depends on your view window. If you remember our initial conditions where it was 8,000 hectares been eaten at the start, so this only goes up to 11, so I'm going to need to think about my y-axis in particular. So if I go Shift V window, well, let's look about the y's first. So I've got a y maximum of 12. Well, I know that after 7 weeks I've got 90,500 hectares. So why don't we go up to 100,000? Something like that, and maybe we'll change the x map. Well, we'll see how it looks. And we'll draw it. And so you can see this is exponentially increasing the amount of land that's been, the area of land that's been eaten by this plague of locusts. So that's the graph. I'm not going to transfer it onto here yet, but I certainly will for part D. So it says, how long would it take for the area eaten to reach 50,000 hectares? Well, I'm basically solving 8,000 times 2 to the 0.5n. I'm solving that equals 50,000. So I need, and you get used to this the more you do it, I need to go back in here, exit, and I just need another line, and it's going to be y equals 50,000. So 50,000, just like that. Draw it, and you can see we've got the intersection, so that's great. Now we can just sort of, as our working, remember we need to show working, and the graph and showing the intersection, showing that you know what you're doing, is working. So if I just, the axes are less important. What is really important is two graphs illustrating the intersection. So I'm going to come around like that, and I'm going to come around like this, and then I'm going to draw a little arrow, and I'm interested, well, where is that point? So I know it's at y equals 50,000. I don't know what x is, so 50,000. The x value that makes that true. So I need to go Shift G solve, looking for the intersection, go straight there, and it says x is 5.287. 5.287. Didn't write that brilliantly, but there you go. There's some working out. You could potentially label these lines, but I think that's probably enough to get the marks. So the question is, how long would it take for the area eaten to be 50,000 hectares? It doesn't ask for a degree of accuracy, so you should assume it wants 3 significant figures. So I'm going to say it takes 5 points. Well, 1, 2, 3. The 8 is the third significant figure. The 7 will make the 8 round up. So 5.29 weeks. It doesn't ask us to try and convert this into hours or anything like that. If it did, that would be a bit tricky, but hopefully you'd have half an idea of how to do it. But I'm just going to leave it like that.